This video will review specific techniques for factoring a polynomial when the degree of the polynomial, or the highest exponent, is greater than 2. We'll talk about the GCF method, the dummy variable method, and then factoring by grouping. The GCF method is basically going to involve factoring out an x, or an x squared. The goal will be to get at least part of the polynomial back down to degree 2 so that we can factor that using our normal techniques. So this method really only works when all terms have at least an x with them. So let's look at this example. We have x to the third plus 15x squared plus 56x. So we're good. They all have an x. So I'm going to start off by factoring that x out. Once I've done that, I'm left with an x on the outside, then in parentheses x squared plus 15x plus 56. Notice that each term lost one x. Now all I have to do is factor this trinomial. And this will be a good review of factoring trinomials with degree 2 as well. It's important to notice here that this trinomial has a leading coefficient of 1. There's an invisible 1 right here. So the method I'm going to use only works when there is that invisible 1 in front. Now I'm going to try to think of two numbers that multiply to 56 but add to 15. So I'll start off making a list of numbers that multiply to 56. And then I'll look and see which add to 15. Well, this certainly doesn't. Nope, nope. Ah, we have a winner. So now, again, since my leading coefficient was 1, I can just go and put those two numbers into my set of parentheses. And I am done. There is nothing more I can do to factor this polynomial. The second type of factoring method I like to call the dummy variable. The basic idea is that we're going to introduce a new variable to take the place of x that will help us factor our polynomial. So this is particularly useful when you see something like x to the fourth and x squared, or x to the sixth and x to the third, or maybe x to the eighth and x to the fourth. Basically, as long as one exponent is half of the other exponent. So the first thing we need to do is define our new variable. And I'm going to say a equals x squared. Now, I could have used any letter, but I felt like using a. So I'm going to rewrite my polynomial using a rather than x. So I still have my 6, but now I have x to the fourth, and I know a was x squared, so this is actually going to be a squared. Then plus 13, and then I have this x squared, but that's actually just a, so a, and then plus 5. And now this is a much nicer looking polynomial that we can factor using our normal methods. Now notice here that our leading coefficient is not 1. So I have to remember that I have to start by multiplying the first coefficient with that constant term. Now we normally call the first coefficient a, but I want to be really careful. It's not this a. We have another a floating around, so I'm just going to say the first with the last. So we have 6 times 5, and that's going to give us 30. And then we have to think of the two numbers that multiply to 30 but add to 13. Please be very careful. They're not multiplying to 5 and adding to 13. They're multiplying to 30 and adding to 13. So here's my list of numbers that multiply to 30, and you can take a quick look and notice that 3 and 10 will be our winner. So then I go back to my original polynomial, and I'm going to rewrite 13a as 3a plus 10a plus 5. So I've really just split that 13. And now I'm going to use the grouping method. So I group the first two and the second two, and I need to pull a GCF out of the first set of parentheses. And I'll notice that I can take a 3a out of there. And then I'm left with 2a in the front, and then just plus 1. And then in my second set of parentheses, I notice that I can take out a 5, and I'm left with a 2a plus 1. Now this is the great checkpoint where you notice that you have 2a plus 1 and 2a plus 1, so it means I did it right. And now I can rewrite the 3a plus 5 in one set of parentheses, and my 2a plus 1 in a second set of parentheses. Now you might think we're done, but you need to remember that we didn't actually start with an a. We don't really care about a. We want to put this x squared back in. So my final answer will be taking this set of these two binomials and rewriting it as 3x squared plus 5 times 2x squared plus 1. And now I am done. This last type I'm going to go through fairly quickly because it's actually pretty similar to what I just showed in the last example. But this is grouping, just kind of standalone grouping. We don't have to do that a times c thing first. We're just going to go and group. So I like to say you do this when nothing else works. So it's basically when you don't have an x in all the terms and you also don't have that nice pattern of x to the fourth and x squared. So here we can see that there is no x in every term. I actually have 4 terms, which already looks a lot different. So I'm just going to try grouping it. Put the first set in parentheses and then the second two in parentheses. From the first group, I'm going to take out 4x squared, and then I'm left with just x minus 2. In the second group, I'm going to take out a 3, and I'm again just left with x minus 2. Again, notice I have the same thing in those two parentheses, so I am all set. So I can just grab my 4x squared and my 3 from there and there. And then my x minus 2, since that showed up in 2 places here. And I am actually all done. So that one was pretty quick. I'd like to take just a moment and look at 2 other really important types of polynomials that you need to be able to factor really quickly without using any other techniques. Just look and factor. The first one is called the difference of squares. Whenever you see a binomial, so 2 terms, that has a number squared minus a number squared, you can always factor that into x plus y, x minus y. So for example, if we had x squared minus 16, that would factor into x plus 4 times x minus 4. We take the square root of both of these 2 numbers and put them in their own set of parentheses on the other side. The second kind is when you see a perfect square trinomial. And those are in the form of x squared plus, I wrote 2bx plus b squared, where b is really just standing for a number. Whenever you see that sort of pattern, that's going to factor into x plus b times x plus b, otherwise known as x plus b squared. And that's why it's called a perfect square trinomial. So for example, if I had x squared plus 16x plus 64, I would immediately notice that the square root of 64 is 8, and 16 divided by 2 is also 8. So that means I would have the nice factoring of x plus 8 times x plus 8, also known as x plus 8 all squared. I'm going to do one last example to really emphasize the fact that sometimes you think you're done, but you're not done, and you actually have to keep factoring. So sometimes you have to factor twice. So for example, I have this polynomial here, and it doesn't look like I can pull out a GCF. It also doesn't look like I can use that dummy variable method. So I'm going to go ahead and group. I'm sort of going to skip quickly through the grouping. Here I've factored out a GCF for the first time, and I have my matching set of parentheses, so I'm all set. And now I've regrouped, but please notice here, x squared minus 9, that's the difference of two squares. So I'll actually finish this off by doing x plus 3, x minus 3, then times 5x plus 3. So I have 3 factors there. So for homework, I'd like you to try to factor these 4 completely. Just a note on the last one, if you can factor out a constant number, that would be really helpful. Good luck.